I'm Ali, co-founder of HackScience. So as I'm sure you all know, scientific research changes the world from breakthrough technologies to life-saving medicines. But scientific research is slow, and a big part of that is that there are a lot of manual processes involved in the research lab. So we're HackScience, and we're accelerating the world's research with affordable lab automation. So as an example of a researcher, we've got Dr. Michael Dell from Imperial College, and he's got great ideas about things to research in malaria. But unfortunately, up to 3 hours of his day is lost to manually replenishing the food source for his malaria cultures. So he's basically got to suck out the liquid food source from each of his flasks and manually replenish it with fresh food, which they call media. And Michael's not alone. There's a lot of researchers losing time to these kind of manual processes. We found that on average 50% or more of the time of a life science researcher in the lab is lost to doing these manual processes. That's a huge lost opportunity for all of us. And additionally to that, there's a huge problem in reproducibility as a result of the fact that people are doing things manually. So when people write a paper about how they've done something, because they're describing a manual process, it's very difficult to reproduce that somewhere else across the world. I think there was a recent paper that said over 80% of protocols that were tried for that paper found in Nature couldn't be reproduced first time. So it's a big problem. So you might be thinking, is a process like Michael's process not already automated? Well, there is an automated option, but it costs £250,000. Takes up a lot of space, really not that easy to use. As you can see, there's a guy babysitting it, even though it's meant to be automated. And this is a trend we're seeing across automation and research today. It takes up a lot of space, it's very expensive, it's focused more towards high throughput. This is not an option for an academic lab, and it's not really an option for a small to medium biotech as well. So that's why we've built the HackScience cell feed, which is basically an automated, affordable cell culturing system. So this basically does all the processes that someone like Michael needs to do. So it replenishes his media, doesn't have to come in on the weekends anymore to look after his cell cultures, and there's a microscope built in so that he can monitor his cells remotely. You can control it from your phone, so you don't even necessarily have to be in the lab, and he can focus on his experiments. So I can give you a quick demo of one of our prototypes back in the office. So as you can see, there's some flasks here. If I hit replenish, it will basically take out the old media and put new media in. For the sake of being quick, I'm just going to add 1 ml of media to this flask. So if I click fill with fresh, it will take some fresh media into the syringe pump, and in a minute you'll see the flask closest to us will tip over, and 1 milliliter of media will come into it. If we just give that about half a minute or so, you'll see it tip over, and there's sometimes a bit of lag on the video at the moment. It should tip over in a minute. Yeah, so it's tipped over. There's 1 ml of media that's going to go in, and then it's going to just rock the flask to make sure you get good coverage of the cells with the media. And this is similar to how someone like Michael's doing it today. But that's not all. So as I mentioned, today when we're doing manual processes, it's really hard to reproduce. So one of the things which is interesting with what we've done is any researcher can basically modify the protocols without having to write any code. So for example, if I decided that for some reason for my cells it might make sense to rock it 5 times, I can create a new button that rocks 5 times. So I can just grab one of these, I'm going to rock tipper 3, let's say 5 times. Let's make a new button, let's say rock 5. Cool. That should work. Cool, you can see we've got this new button that says rock 5, and if I press that, we should see the flask nearest to us rock 5 times. So, people can create new protocols and now share them with their papers. And it's really as easy as copying and pasting the protocols from here. So I'll just quickly show you that, and then I'll jump back to more of where we're heading with this. So I'll just show you this. So say this new protocol that we've created. We can export that as text, have it as supporting information on our paper, and then someone around the world who has another cell feed who wants to replicate it can simply import that protocol, and there we go, it's ready to use as well. So we see this basically turning into like some kind of protocol sharing online, a bit like GitHub, where people from different labs around the world can share protocols that work for their cells. And we also have the built-in microscope, and because people are doing experiments on the same platform now, you can really aggregate data sets, and people can start to benefit from each other's work, by building algorithms, for example, on top of all the aggregated data sets. So this is just part of our vision. We see automation fitting into these two different buckets. We got like the productized or kind of single-use automation, like the cell feed, which is for very repetitive workflows that are similar across a lot of different labs around the world. On the other side, we see modular reconfigurable automation. So we're testing out this idea now as well. This is, saying, I want to do a new experiment in the lab. Instead of grabbing a flask and a pipette and a manual heater, I'm going to grab an automated pump, automated valve, some sensors, and basically this works again with the same protocol building thing I showed you. And that means that even from day one of doing a new experiment, people can do it in a way that's easy to reproduce and easy to share how they've done it. And on top of both of that, we hope that come out these clean crowd-aggregated data sets that people can start to pull out interesting insights from. And so that's what we're up to. Feel free to get in touch with me at ali@hackscience.io. We love hearing from both researchers and just anyone who's interested. And also at the moment, we're looking to add someone to our team who's got a background in cell culture, so we're looking to add another cell culture person. So if anyone's interested in that as well, just reach out. Thanks.